question, an electron heads to the right at a speed of 2.2 e to the 7th meters per second. It is forced down by a magnetic field with a strength of 5.4 e to the negative 4th Tesla. Now, letter A asks us to find the direction of the magnetic field. Well, we're going to use the right-hand rule, but with the left hand because it's a negative charge. This finger points in the direction of the velocity, which is to the right. The magnetic force is making it go down. So that means the magnetic field would be in. Now we're asked to find the magnitude of the magnetic field. This is just a simple F equals QVB problem. Q is the charge of an electron, which is 1.6 e to the negative 19th, times V, our velocity, 2.2 e to the 7th, times our B, which is our charge in the Tesla charge, 5.4 e to the negative 4th. That will equal our force. So I'm going to type that out. (1.6 e to the negative 19th times 2.2 e to the 7th times 5.4 e to the negative 4th. Bam! Force is 1.9 e to the negative 15th. Now we're asked to find the radius of curvature. The equation for this is the equation for centripetal force. Force centripetal equals mv squared over r. Now, this is our force, what we found in letter B. So 1.9 e to the negative 15th equals m would be the weight of an electron, which is 9.1 e to the negative 31st, times v squared, which we know, 2.2 e to the 7th, squared over r. And then we solve it for r. How we'll do that is these two will switch places. We'll take this, we'll type out the top part, divide it by this to find our r. 9.1 e to the negative 31st times 2.2 e to the 7th squared, then divide that by 1.9 e to the negative 15th. Some gazelles are running around. Our r value is 0.232. Now here for the rest of the problem.
Yes, thank you, Jake. Assume now that an electric field is established in the same region as the magnetic field so that the electron now passes through undeflected. Find the value of the electric field. Okay, I'm going to take his numbers from last time and we are going to take this equation. We are trying to find E. We have F from part B. We plug 1.901 e to the negative 15th over, should be this, we get for E this big number, 11,881.25 is the value of the electric field. Now for part E, this is just basically working in reverse. If you go back to part A where we use the hand tricks, if the field was pointing into the paper, to cancel it, it's got to come out.